In this video, we're going to be talking about some math basics in Java. We're also going to talk about some shortcut operators in Java that we can use. And then we're going to talk about the different built-in math functions. So some math basics in Java that are applied pretty much across a number of different computer science programming languages are that addition, subtraction, and multiplication really work just as you would expect them to work. If you add, subtract, and multiply two integers, the result will be the exact integer answer. So 3 plus 2 is 5. 5 times 3 is 15. Those types of things are consistent. The same thing happens when you have double variables. If you add, subtract, and multiply two double variables, the result will be that exact double answer as well. So addition, subtraction, and multiplication work just as you would expect them to. It's division where things differ. And what you have to pay really close attention to in Java is that the type of number that goes into that division problem really dictates what the answer is going to be. Now, the first thing you need to note here is I have two different sets of division problems right here. You can see 12 divided by 5, and you can see 12.0 divided by 5.0. The difference here between these two problems is that this 12, because it doesn't have a decimal point, is an integer. This one is a double. And so if you're using variable names in your math equations, you really have to pay attention to, was that variable an integer or was that variable a double, because it's going to ultimately change, the answer that you get. So you can see here we have pretty much identical math problems, but if you divide two integers, so here you can see there's no decimal point, it's simply going to give you an integer answer. So it tells you how many times the second number goes evenly into the first. So 5 goes into 12 twice to get to 10, and the result is 2. 5 goes into 19 3 times because we can get up to 15, and the result is just 3. There's no decimal point on them because if you have two integers being divided, your result is an integer. Now, the same thing happens with doubles. If you have two doubles being divided, the result will be a double. So you really have to pay close attention to what type of number did I type in? Does it have a decimal point? Does it not? And what type of variable did I create this variable to be? Was the variable an integer or is the variable a double? And that will impact how the math works. Now, the modulus operator is something that is also used between two integers. So the modulus operator, what it does is it finds the remainder after integer division has taken place. So for example here, 16, the integer, divided by 5 would give us 3, right? Because those are two integers being divided. 5 goes into 16 3 times completely to get to 15. We have a remainder here of 1 left over, okay? So it goes in there 3 times, but we have a remainder of 1 left over that gets us to 16. That's what the modulus operator is. 16, you're finding that remainder after the integer division has taken place. Same thing here, 20 divided by 12 using integer division is going to be 1. 12 goes into 20 1 complete time, but there is a remainder of 8 left over because we have to get all the way up to 20. So just kind of keeping in mind what the modulus operator does, it works hand in hand with integer division. So you wouldn't use the modulus operator with a double because you wouldn't be looking for a remainder after division, because a double can give you a double answer that contains a decimal. Now, where this gets a little bit tricky, and it's really not that tricky, but you just have to watch your variable types, is if you perform a basic operation of mixed types, which means you have an integer mixed with a double, okay? If this happens, if you have an integer mixed with a double, the answer defaults to the double answer. So, or to the more inclusive variable type, which is the double. So what that means is that if you have a mixed type, because doubles are a little more inclusive and welcoming they can take integers in, but integers cannot take doubles in. Because the double is more inclusive, the result will be a double. So if you have integer divided by double, it's a double. Double divided by integer, it's a double. And you can see how if you mix them, the result is always a double. So you really have to pay close attention to, am I using two integers or is there a double in the mix? And if there's a double in the mix, then your result is going to be a double value, and you therefore have to, save it into a double and all of that jazz. So now if we take a look at this here, we're just going to deal with some of the variables up here and kind of talk through what's going to happen. So this first one here, we can see we have variable 1 divided by variable 2. So I can see that I have two doubles. I have 17.0 divided by 14.0. And because of that, when I perform that particular division, I'm going to get something like 1.2142857, and it goes on and on and on. Because I'm dividing two doubles, my answer is going to be a double. Now this next one mixes a double with an integer. And even though it's mixing a double with an integer, the result is not going to be an integer. Remember, it goes to the most inclusive variable type, which is a double, if we have one of each. So this is 5.66666 repeating, and it continues on forever. This next one here, we have 14.0 divided by 3, which is a double mixed with an integer. And so again, this, because we have mixed, is going to be a double answer. And finally here we see we have 14 integer divided by 3. This one, because we have two integers, is going to have a result of just an integer. So we have to figure out how many times 3 evenly goes into 14. Well, 3 times 4 is 12, right? And then it can't go in any more than that because 3 times 5 would be 15, which is higher than 14. And lastly here we have 14 modulus 3, and remember the modulus finds the remainder after this division here. So 3 times 4 is 12, which means we have 2 left over to get to 15, so our modulus operator here would be 2. So just really paying close attention to variable types and how division and the modulus operator will work. So then from here, the next thing we need to talk about is how the order of operations applies in Java. So the order of operations applies pretty much just like it would work in math. The only difference is the addition of that modulus operator. So if you see parentheses, which remember parentheses are going to be anything that groups, so that can be brackets, parentheses, a square root, something like that. Those always come first. The next thing we're going to be dealing with are exponents. That's what our E stands for, are our exponents here. And then here, when you see M, D, and modulus, we're just going to work multiplication and division from left to right, along with the modulus. So we just go left to right, and we perform whatever operation we find. And then finally, we would end with addition and subtraction from left to right. So keeping this in mind is important because when you give your computer instructions, you need to make sure that you communicate those instructions well. Now, the tricky part about this, and what we're going to work on the next slide, is that you need to be really, really careful with your integer and double division. You have to really pay attention to those types, or you very well might get one wrong. So we're going to start here. And I know this looks like a lot of gobbledygook. We're going to do our best to clean it up as much as we can. But if you take a look here, you notice we have a lot of multiplication, division, modulus, subtraction, addition. And we're going to go first to the parentheses because parentheses always come first. And then I notice there's a lot of different operations happening inside of these parentheses. So what I see inside of these parentheses is that I have a modulus, a division, and a subtraction. And so what I'm going to do is I'm going to work the order of operations, start on the left-hand side, and I'm going to start with multiplication, division, and modulus. So I'm actually going to start right here with this first step, because that's the first thing inside of there that would come. So I'm not going to touch this first part here, right? Just going to leave it all alone. But I'm going to figure out what 30 modulus 7 is. And because these are two integers, remember it's going to find a remainder that is an integer. So when I think this through, I think, okay, we have 30 modulus 7, which is going to result in a value of It's going to result in the value of 2 because 7 goes into 30 4 times and has a remainder of 2 left over. So we have 2 divided by 2 minus 6. So that's the first step there. Then from here, I look next inside the parentheses and I see division. So again, I'm going to start with that next step. I'm not going to touch the first part here. I'm just going to leave it all alone. And 2 divided by 2, now luckily that's a nice integer answer. It's not always the case when that happens. But when I look here, what I notice is that we have 2 divided by 2 is 1. Luckily that's an integer answer, but I also need to note that those are 2 integers. So regardless of what my answer would be, the answer has to be an integer. And there we have our next step. Now, after this, we would do our subtraction because that's the last thing inside of our parentheses. So we're going to leave the rest of this completely alone. And we have 1 minus 6, which is a negative 5. Now, from here, the next thing I'm going to do is I'm going to look at my division, multiplication, and whatnot that's outside of the parentheses. So when I look, the first thing I see here is I see a nice integer division problem. 24 divides by 4. Remember, we're doing division, multiplication, and modulus left to right first. So 24 divided by 4 is a nice 6, which is really nice. And then from here, our next step, we do our multiplication because that's the next thing from left to right. That's out of the multiplication, division, modulus categories. That would be 30. And now most of this has seemed pretty straightforward. Where this one gets tricky is this part right here. So this last step right here is division. But what I notice is I have 2 integers. Because I have 2 integers, my result needs to be an integer. So this is where paying attention to types is super important. If you do not pay attention to types, you will get the wrong answer. 30 divided by 8 as integers is just asking how many times does 8 go into 30. 8 goes into 30 3 times equally. So we can't have any sort of decimal answer there. It is just the integer. How many times does it go in completely? And then finally, our final answer is that last addition problem there, and it gives us negative 2. So I'm going to shrink that up a little bit to give myself more space for the next problem. But you can see how we got to that answer, and it's just by being really careful with all of our work. So I'm going to do the same thing here, and hopefully this one will go a little bit faster just because it's the same numbers. The only difference in this is that we have doubles here and we have doubles here. So we're going to see how the change in doubles impacts this problem. So I'm going to, again, leave the first part completely alone because that part doesn't matter right now, right? Because we're dealing with parentheses first. And again, we're going to start with this same step right here. So we have 30 modulus 7, which again is finding the remainder after integer division. So 7 goes into 30 4 times with a remainder of 2. So I have 2 divided by 2.0 minus 6. Then from here, my next step is still inside the parentheses and is this division problem. Now, because I have a mixture here of divisions, what I need to make sure I do is I need to be careful here and think about the type of answer I'm going to have at the end. So we have 2 divided by 2.0. Now, because I have an integer mixed with a double, while the answer is still 1, it needs to be written as 1.0 because it's a double answer if we have a mixed answer there. So we can't leave it as an integer anymore. It needs to be a double because it was mixed with a double. And then next we can see here that we would do our subtraction, leaving that first part alone. And again, because we have a mixed type here, 1.0 minus 6.0, our answer is negative 5.0. Again, notice this is written as a double because it was a double mixed with an integer. So now we can move on to this next piece here. So we have 24 divided by 4, which 2 integers. This needs to be an integer answer, and luckily it is. Our next step is our multiplication, and again, 2 integers, so our result is an integer. We need our little negative signs in there. Now, the next part where this is different is with this division right here. Because this division now contains a double, it has to have an answer that is also a double. So 30 divided by 8, 0.0, the double version, is going to be 3.75. Notice it's not 3 this time around, it's 3.75. And then we can add on the 5.0, or that negative 5.0. And because we have two doubles, our answer is going to be a double. So you can see here how just because we had those two changes, they are the same numbers, but the big difference here is that they were doubles and not integers, and that's going to change our final answer. So really paying close attention to those statements and noticing how the answers slightly differ when we do have doubles instead of integers. Now, the next thing I want to talk about are some of the shortcut operators that exist in Java. So you can see here that we have increment and decrement operators that you can just use to quickly add one or subtract one from a variable. So if you've programmed before, you know that this statement will take the x value, add 1 to it, and resave it in x. If you want to do this more quickly in Java, you can simply write the line x++, and that will automatically do this same statement. And the same thing here with x minus minus. If you know you need to just subtract one, you can use that statement as well in order to, create a quick statement that you don't have to type out the full math for. So you can use those quick statements if you would like to quickly increment or quickly decrement a variable by 1. Now, some other operators that are kind of cool that you do have to add numbers to, but you can use, are these compound operators. So you can see here, these are all statements we would write into Java. X plus 3, x minus 4, you multiply it by 2, divide it by 4, or find the modulus. And what's kind of cool here is that you can use these operators to quickly do those same things. So you see here we have x plus equals 3. That's a really fast way of writing x equals x plus 3. X minus equals 4. Again, a fast way of writing x equals x minus 4. And the same thing applies here for multiplication, division, and modulus. So you can use these quick operators if you like to quickly write these types of statements into your code. Since they are so common, these quick statements here will allow you to quickly do those things if you know that that's the end goal of your program is to, add 3 minus 4, etc., etc. Now, the next thing we're going to take a look at before we write a program together are some of the built-in math functions. Now, in order to access these built-in math functions, we need to actually add the following line of code in at the beginning of your program. So if you want to use the math functions, you need to type in import to import in java.lang.math.star. And please note that there's a .star here. That .star is going to bring in all the math functions. So what you need to do here is type this line before your class heading at the very, very beginning, kind of where you imported in Scanner. And what you're going to do here is you're going to use this line of code to import in a bunch of built-in math functions, which you can find right here. So we've got a bunch of different math functions that we can use in Java that are built in. Now, to access them, you always start with capital math, so capital M, dot. So notice that's going into the math class. That's how we go into the math class to access that particular function. And then after that, you put the function command and you provide it with any parameters should it need some. So this first one here, the .abs, this one is simply absolute value. So if you put a number inside of those parentheses, a number or a variable, it will find the absolute value of that particular function. This one, the max function, will find the maximum number of the two numbers that you entered. This one here will find the minimum number of the two numbers you entered. So notice you could enter in maybe two variables in either one of these, and it would spit out either the max or the minimum. Math.round is going to round a number appropriately, which means if it needs to round up, if it has a decimal point of 0.5 or higher, it will round it up. And if it has a decimal point of, point lower than 0.5, it will round down. Then from here, math.sqrt because that looks like the word square root. That's exactly what it does. It finds the square root of the number that you put inside of that function. Cube root, or CBRT, stands for cube root. It's going to find the cube root of that function. Pow is going to take the first number to the power of the second number. So you can see you enter in two numbers there. Takes number 1 to the power of number 2. Ceiling is going to essentially round that number up. Whatever number you put in there, it's going to round it up to the nearest integer. And this one, the floor, is going to round that number down to the nearest integer. So they're all popular things that we use, but you can now use these instead of having to write your own code. You can now just use these functions if you would like to find those values quickly. Make sure you save those values into a variable or print them somewhere so you know what they are, but you are capable of using these math functions should you like to. Now, this last one here where it has math.pi, this is just the value of pi. So if you need to use the value of pi, say you're finding the area of a circle or something like that, you can access the value of pi by doing math.pi, and notice there are no parentheses. So feel free to use these as much as you need to in order to actually do math functions or math calculations of these types a little more quickly. Now, what we're going to do is we are going to write and create a new Java program together. So what our program will need to do is it will need to welcome the user to the program. So we'll have to describe what its purpose is so the user knows what to do. It will create the variables needed to hold the values throughout the program. It will ask the user to enter in the radius of their circle, calculate the area of their circle, and then print the area of their circle to the screen. So what I'd like for you to do is head on into Java. And what we're going to do is we're going to create a new program. So I'm going to go to my replets and I'm going to go to Java Unit 1. And in here, I'm going to create a new program. Now we need to make sure that we use Java to create this program. So I'm going to do Java here. And then I'm going to name this program Unit 1 Lesson 5 Circle Area. That way I know exactly what lesson it went with and its purpose. So I'm going to create this replet. And as I do so, remember it automatically creates that main function for me. Make sure you start by deleting out this hello world piece because you don't need that in your program. And then I am going to space out my brackets a little bit just because I like to be able to see the start and end of my brackets. So there's our main function. Now what we need to do from here is we need to make an additional class. So I'm going to create a new file. And remember, the name of this file is what's important. That's what we're going to need to be consistent with as we program. And I'm just going to call this circle with a capital C and area with a capital A and no spaces .java. So that creates a new class for me called circle area. And then I'm just going to put my skeleton code in there. So I have public class circle area. Notice that circle and it has the C and the A that are capitalized. And then I'm going to add in my brackets and I can see the start and end of my class. Then from here, I'm going to do public static void main string with the square brackets, space args, parenthesis, and then again, add in my two brackets. So that creates the skeleton code for my class that's going to hold all of the code that circle area needs. Now, the last thing I need to do to make sure that circle area runs is I need to go back to my main and I need to type in circle area, my class name that I want to run, .main, and then put args in the parentheses with a semicolon at the end. So this is just our general setup piece so that we can make sure that we are all set up to run this program when we have our code written in circle area. So make sure you have main looking just like this and circle looking just like this so that when we write our code, everything works as intended. Now, if we look back at our instructions, the first thing we need to do is we need to welcome the user to the program. So we can do system.out.print. I like to do print line, and I'm just going to write welcome to the circle area calculating program. lets people know what this program is about, what it's going to do, and I add my semicolon onto the end. Then the next thing I need to do is I need to create my variables. Now, creating my variables, I need to think through very carefully what types of variables I want. Do I want decimal answers or do I not? And because I do in this case, I need to make sure that any variables I create are going to actually hold decimals if I want them. And so I'm going to create my variables here. So I'm going to make a little comment there. And what you're going to see as I do this is I'm going to use doubles. And the reason I'm going to use doubles, so I have double radius, that's going to hold the radius of my circle when the user enters in the radius. And then I'm going to create double, hold on there, one second. I'm going to create double area. So the purpose of my program is to calculate the circle's area. I know that the equation is the area equals pi times your radius squared. That's how I find my circle area. So the reason I need radius and the reason I need area as variables are because those are the two values that I'm either going to get from the user or calculate. Now, because I want variables to have decimals, I need to include the double part. So here I've declared these two variables, and then I need to initialize them to have a value of 0 to start, just so that they have a value in there so that if something goes wrong with my program at least knows what to do if it has a radius of 0 and an area of 0 already defined. So we've got our variables named. That is great. And the next thing we're going to do is we're going to add the ability to put input into our program. So I need to add input into my program. Now, in order to do this, I have to import java.util.scanner. Remember, if we don't include this particular line of code, we will not be able to use the scanner, which means that we won't be able to actually write our program because we won't be able to get any input from the user. So make sure you add in this line of code. Then the next piece is if I want to use this input, I need to add a scanner object into my program. So I'm going to create a scanner object for input use at some point. So I have scanner. I'm going to name this scanner in. I'm just very consistent and like to use the same names. I have new scanner system.in and then my semicolon. So far I've added input in. I've printed a welcome message to the screen. I've created my scanner object and I've created my variables. Now, if I actually want to ask the user to enter information into my program, remember that I need to actually prompt them. So these next two lines of code are going to gather input from the user. The first line is going to display what I want them to see. The second line is going to gather the input and save it into the variable called radius. So here we have system.out.print, and I'm going to write, please enter the radius. Ooh, I don't know what I did there. Hold on. Please enter the radius. Let's see. Let's try to sync to shared there. All right, we'll start from there again. So it says, please enter the radius of your circle. I'll put a semicolon there. Now notice I used print here instead of print line because I don't want it to go down to a new line. I want it to just print and then have that colon there and prompt the user. So this first line prints to the screen. The second line, I'm doing radius equals because I want to save the value into radius. And I'm going to do in my scanner object name dot next double to gather the next double that the user enters. And so these two lines of code are going to prompt the user to enter in a radius and then gather that radius value from them and save it inside of the radius variable. Now, this next piece here is where we're actually going to use our math. So remember, if we need to do the value of pi and radius squared, we need to import in our math functions if we want to be able to use those. So fix your T on import if you didn't notice that before. And now we're going to add the math functions into my program. So to do that, we type import, just like we did before. And we're going to do java.lang.math with a capital M. dot star. And please don't forget your star. You won't get all the functions that you need. So the next line is where we're going to type in the math for our program. So we're now going to calculate the area of our circle. So because we're doing that, we're going to have our variable for area on the left to capture this variable. And the equation, remember, is pi and then radius squared. So the first math function that I need is I need the pi value. And remember from our earlier slides, we saw that the pi value is capital M in math dot a capital P and a capital I. What that's going to do is that's going to bring the pi value straight into our program. And that's going to give us the most exact answer that we could possibly have. Then we're going to multiply that because it's pi times radius squared. And then we're going to use the power function because that's how we get something squared. So again, I'm going to have capital math dot pow. And because I want my radius raised to the second power, I'm going to do radius comma 2. And what that's going to do is that's going to take my radius value and square it. And then we're going to multiply it by the pi value. So the last thing I need to do here is I need to print this value to the screen. So we're going to print our output to the screen. So we have system.out.print. I'm going to do this on a new line. And I'm going to print area of your circle is. I'm going to put a space there. And then I'm going to concatenate this together with the area variable. And I'm going to smush those two together and print it to the screen. So now let's run our program and see how it does. So it's compiling, everything looks good. It says, welcome to our circle area calculating program. Please enter your radius. I'm going to enter in a radius of 3 and check this on my calculator as I go. So I know pi times 3 squared, if I calculate it right now, is 28.27. So let's see if our program does that correctly. And look, there it is. So our program works just as expected using our math functions, using our gathering input. We were able to create a program that now calculates area for us.